Hello YouTube, this is Richard. I bought this B&K Precision 880 LCR meter, and as there are no videos about the 880, I thought let's do a video. It's not my habit, I don't do videos, I'm not very good at it. English is not my native language, I'm Dutch, so please bear with me and be a bit of forgiving in your comments. It's just what it is, you know. I will make some mistakes. I maybe suddenly shut off the video and then continue. Well, that's just how it goes. I bought this thing because I'm in the electronics hobby, and although I'm not all that knowledgeable, I know by now that electrolytic capacitors get old. And the way to check an electrolytic capacitor is to measure its ESR, its equivalent series resistance. When it gets old, it starts behaving like a resistor, more or less. And you have to check them out. I'm a bit in the hobby of CB radios, televisions, old electronics, amplifiers, tuners, etc., etc. So I, at some point, decided I need a good LCR meter because the Fluke I have can measure capacitance, but it doesn't have the ESR measurement capability. So I came to the BK Precision after looking at several meters and discovering that some of them have the 4-wire Kelvin measurement and some don't. If you don't know what that means, look it up. It's called a Kelvin measurement or a 4-wire measurement. And for measuring resistance, it means you are so much more accurate than a standard 2-wire measurement. That's why this meter is a little bit more expensive than the 879 and the 878, which doesn't have that. So read up on about it and maybe just as me come to the conclusion that it is worth some extra money to buy a more expensive model which has this capability, which just makes it a better meter. The way it works is that instead of 2 wires like the normal crocodile clips, which you can also use with this meter, you just stick them in here. In this case, you have the measuring current and the voltage measuring in one wire, and one makes the other one go bad. So you want that separated. You want one wire for the measuring current and one wire which actually does the measuring. So 4 wires all in all. And that's called a Kelvin measurement. So you end up with something like this, where each clip has 2 wires which are completely separated all the way up to the end. So one wire goes here and doesn't make a connection with that one, and vice versa. So these are separately all the way up to the end. So you have the supply current separated from the measurement, and that makes it more accurate. It does it by means of this adapter. Now all these meters have more or less the same adapter. The one from BK Precision, and I also think the Agilent, have the little hook on it which makes that it can lock. So you stick it in, push it to the right, and now it's locked. The other ones are just push in and that's it. I do think that all these accessories from all these meters fit in one another. So you could use the Agilent clips and stick them in a BK, or use the BK clips and stick them in a Agilent or in a GW Instack or in an Isotech. It's all the same stuff. This is a sort of standard. I'm not sure about that, but I think it works that way. The 880, although it's a little bit more expensive, I paid 350 euros for this. delivered at my doorstep in Europe. It comes from the United States. I ordered it in America. In Europe, with companies like Farnell and RS Electronics, this meter costs something like 450 to 500 euros. And I've seen even higher prices than that. But let's say 450. I paid 350 for it. But then it had to come from America, and you have to make sure you buy the 220 volt model. If you don't do that, you get the 110 volt model. The meter itself is the same. It's the wart, which you get delivered with it. This comes with the Euro plug, the 230 volt. It's 230, yeah, it's 230, 50 hertz. It's a real wart. It's a real linear power supply. It has a copper transformer in it, so it's not a switching power supply, which is rare these days. Maybe they have done this because of interference with the meter. I can imagine that these type of meters are very sensitive and that a switching power supply is just too difficult and makes too much interference. Anyhow, it's a nice piece of nostalgia, and for me this reeks of quality. You know, having a real copper transformer, a linear power supply. Anyhow, it's 12 volt, 150 milliamps. It charges the 9 volt block, which is in here. It has a 9 volt battery, nickel metal hydride, which also comes with the meter. It's Chinese, a no-name brand, but it works. You could change it for a brand battery, something like Varta or Duracell. At the end, they all come from China, so do whatever you want with it. Unfortunately, it's not the lithium-ion battery, but hey, it should work. I'm not sure which type of nickel metal hydride is in here. Nickel metal hydrides have a tendency to how do you call this? They run flat by themselves in a rather high rate. But since a couple of years, there is a new type of nickel metal hydrides, which they call always ready. They're more or less like an alkaline battery. They only lose a few percent of charge per year instead of a few percent per month. I'm not sure whether this is that type. Maybe I switch. I will see that in the future how long it will last while it's on the shelf, waiting for the next time I'll use it. My experience with rechargeable batteries in devices which have a soft off, like this one, there is a standby current. It's probably very low, but it means it runs the battery flat after a month or 2 or 3 or 4, whatever. We will see. Like I said, the meter is fairly complete. It comes with these Kelvin clips, which is a nice thing. It comes with Kelvin tweezers to measure SMDs. These are, well, they're nice. They're not tiny, but I think they will suffice for most SMDs. And of course they're the Kelvin type, so you have the double wires, blue, black and red and white. So it's a real Kelvin measurement. So you get that. You get the 2 banana clips. You get a USB cable with it to make a connection with a Windows computer. The software is not with the device. You have to download it from the website. It's the software and the USB driver. From what I've seen, the software replicates the meter, and I think it adds logging capability. I'm not sure of that. It comes with a shorting plate, which you need to calibrate the meter. You just stick it in here to short out the 2 terminals. So that's about it, what you get with it. Yeah, and of course this quick start guide, which is of no use. It's just a pamphlet which tells you nothing. Let's open it up. Yeah, this is it, and this is how you plug it in. You have to download the manual from the website from BK Precision. Reading it just once is enough. It's fairly simple to use, the meter. Once you understand how it works, it's self-explanatory. You don't need the manual a lot. What can I say about this meter? Let's switch it off. If you switch it on, it will show you the firmware. Maybe it's firmware upgradable, but I don't think there will be ever an upgrade for this meter, like there is never an upgrade for multimeters like the Fluke. It just isn't necessary. You could add some functionality because there is some functionality missing, or maybe not the functionality I would like, but hey, I don't think there will be ever a firmware update for this thing. So that's that. It has a background light which you can switch on and off. No matter what, the background light will always go off after, what is it, 1 minute, 2 minutes, 3 minutes, something like that. The standby function of the device, so the sleep mode, is disabled if you connect the wall wart. If you connect the wall wart in it, the adapter, it stays on forever, which is a nice thing. And then also the background lighting stays also on forever. So this means you can put it on your bench and use it all day long without having the light to switch on and off or the meter to switch on and off. That's a nice feature. Beside that, it has a utility menu in which you can change the standby times from 5, 10, 15 minutes to up to 60 minutes, and you can switch it completely off. Functionality, you can change. It's an AC meter, so no matter what it says, it will always use AC to measure. It has the possibility to give a DC, let's see, where is it? There it is. There it is. DC resistance, but even in this mode, it will still apply an AC current. It's a block wave, how do you call this? Blokgolf. I can't find the word for it. A square wave, sorry. It always applies a square wave, no matter what. It applies a square wave in DC resistance modes. In the other modes, it applies a sine wave. So it's never a DC fixed voltage. If you have a device to be measured and it needs, for some reason, it needs a DC measurement, you cannot use this meter. The manual tells you about this. I have no idea if there are capacitors or resistors or coils which need a DC value. I can't think of anything. But then again, I'm not all that knowledgeable in electronics at this point in time. Anyhow, it's an AC meter. You can change, let's put it in. So with this button, you change it from inductance L to capacitance C, resistance R, Z is impedance, so that's complex resistance, to DCR, which is DC resistance. Let's put it in capacitance. In that case, you can change the measurement frequency from, let's go to the beginning, 100 Hertz, 120 Hertz, 1 kilohertz, 10 kilohertz, and 100 kilohertz. You can change the measurement voltage level from 0.3 volt to 1 volt to 0.6 volt, which is the standard. You can change the measurement rate, the refresh rate, or the measurement interval from slow, in which it has a nice display. It's still, you can see 23, 22, 23, 22, 21. But if you put it on fast, it goes berserk. I think this is not necessary, but hey, it's there. Maybe you got a need for that. So you can put it in serial mode or in parallel mode. The standard is parallel mode for capacitors. If I'm right, small capacitors are usually measured in parallel mode. Large capacitors are measured in serial mode. I still have to learn about that. It has a calibration. You have to calibrate it for an open position. Now it's open. Press it again. That's the open. If you put in the short plate, it says calibrator short. Press it again, and now it's completely calibrated, but it is calibrated for 100 kilohertz. If you change the frequency, you have to recalibrate if you want the highest accuracy. If you just want to do a normal measurement, you know, the accuracy is not all that important. You can do without the calibration. It is not explicitly necessary every freaking time. Okay? It will still do a measurement, but it will not get the last digits in accuracy. The same goes for using the Kelvin clips. You stick in the Kelvin clips, you put it on calibrate, it says calibrate open. Well, it's open at this point, so that's confirmed. You put it in, connect them together, you put it in short, calibration short, and now it's calibrated for the Kelvin clips, and it can do crazy accurate measurements. So let's do that with a resistant measurement. This is a gold-plated piece of bronze, I think. Not sure what it is. I think this is a piece of bronze which has a little gold plating on it. So we put it to resistance. It's in megohm. So first of all, let's put it on slow, put it on 100 Hertz, which is sufficient, 0.6 volt. The short calibration, that's one. Put the open calibration, that's the other. And now try to measure this plate. So in short, it should read somewhere close to 0 ohm. And it does. You see 0.67, and it really depends on small differences. So we can do the short calibration again if we want to make it even more accurate. Now it's 0.035. That's crazy little. So you can see it can measure that. If you make it across, it will be even longer. 0. So that's 7. What's that? 1/10 of a milliohm? Yeah. Yeah, because it's 1/10, 100, 1 milliohm, 1/10 of a milliohm. So that's really small, you know. So you can measure tiny pieces of wire with this. That's how accurate it is. And that also means that no matter what capacitor you stick in it, no matter how small the equivalent series resistance is, it will be able to measure it. That being said, what are the other things? Oh yeah, you have the secondary display. So you have the primary display, which displays the value. Let's take a coil, for instance. So we put it in L. There's L, inductance. And we put a little inductor here. and it should be in parallel mode. And at 100 Hertz, and of course I have to connect this. So it's 233 microhenries. And then secondary, in the secondary display, it can display a few other things. It can display the D value, the angle value, the ESR value, and the Q value. Q factor, D is dissipation, the factor corner, the angle. So that's about it. That's what is more or less to say about this thing. It's a very nice meter. I think it looks robust. It has a nice stand. It can stand. You can push the buttons without it moving too much. You should put it somewhere stuck, so that's better, you know. Maybe on a rubber mat it will stay there. It's fairly stable. It has the connector. It has the USB socket for connection to the PC. Maybe later on I will make another video of connecting it to the PC and also show you what the output of the device looks like. I can tell you now it's a sinusoidal, and in the DC resistance mode it's a square wave. That's about it. Looks nice and clean. Onto frequency, 100 kilohertz is really 100 kilohertz, and 0.6 volt is really 0.6 volt. So there's nothing to complain about that. So that's it. That's about it. That's what I had to say about this meter. I hope you enjoyed it. I hope you can make your decision and up if you want to buy one. Also one, I can recommend it. I think it's a good device. I think I will have years and years of, well, at least I hope, we'll have years and years of trouble-free happiness with it and do a lot of measurements with it. So that's about it. Thank you and bye-bye.